Hello, my name is Savanmani Rijhun. This is my video 5 assignment on kinematics or kinetics of a rigid body. Let's get right into it. Here we can have here we have a picture of a self-driving motorcycle taken from CBS Philly, and here we have the problem statement. The self-driving motorcycle has a mass m and center mass of g. The back wheel of the motorcycle always slips, while the front wheel rotates freely. The coefficient of kinetic friction between the wheels and the road is mu. Write the equation of motions for the motorcycle. Neglect the mass of the wheels. With that, we can get right into the assumptions. We can assume that the motorcycle is a rigid body and it has a center mass of g at height h. And like the problem said, we can neglect the mass of the wheel. And we can label the wheel A and B. A for the front wheel and B for the back wheel. And with that, we also have the distance between the wheels to g. And for the front wheel, we can assume the distance to g is x1, and for the back wheel b, we can assume the distance to g is x2. We also can assume that gravity acts on the system. Here we have the free body diagram and the inertia. As you see in the free body diagram, we got the weight, the height, the friction force that is pushing a motorcycle forward, which is mu, and the normal force of wheel B. And here we have the inertia diagram. It's the mass times the acceleration in the x direction, and it's going to the left side. Once we got those free body diagram, we can write out our equations of motions. First off, we see here F force B, force of wheel B, is the same as the friction force, which is mu times normal force of B, and x direction is the mass times the x directional acceleration, and with those two we can get mu times the normal force of B equals to the mass times acceleration in the x direction. And for the y direction, we know that the equation will be equal to 0, and the equation is the normal force of wheel A plus the normal force of wheel B minus the weight of the system equals to 0, and we know it's equal to 0. And finally, we also have here the moment of the entire system. We also know the moment is equal to 0, and it is negative normal force of wheel A times the distance x1, and it's negative because it's going in the clockwise direction from point G. The same can be said about the mu times normal force of wheel B times the height. It's also going in the clockwise direction, so it's negative. And finally, it's the normal force of wheel B times the distance x2. This is in the positive direction because it's going in the counterclockwise direction. And with that, we have all the equation of motion for this self-driving motorbike. Thank you very much for watching this video.